this is your margin of error. All right, and the X bar, you can think of it as the center. And same with the P hat, you can think of it as the center.
Okay.
All right, and the idea is that the confidence intervals, they get wider under certain conditions and narrower under certain conditions. Wider, for example, if you go from, say, a 95 to a 99 confidence interval. And that's kind of some stuff I'm seeing like more towards the end of the of this, but that's kind of a key thing here. You can see that it's also affected by sample size. So it gets narrower, like as let's just say n goes from 100 to 400, it gets narrower. So the sample size matters as well. Really, those are the two things that affect confidence intervals.
Okay.
Right, now we should just look at some problems, because the best way to kind of explain this is to go through some problems maybe you haven't done yet. And I'm looking at number 2. It says in an earlier assignment. Does
Okay.
is that okay?
Yeah.
All right, so the problem here says in an earlier assignment, you determined that for a 99% confidence interval and a sample of 550 people was 0.165 confidence level in the same proportion. Oh, this is different. I'm sorry. This is not what I wanted. This is going backwards. We don't want to do that quite yet. I apologize. Let's go to, we don't want to do this. We'll do that later. That comes after we learn this other stuff. So I'm seeing like a table or sorry, I'm just trying to get some bearings here and what to work on. I guess we'll work on this question 3 maybe.
Okay.
In a poll taken in March of 2007, Gallup asked 1,006 national adults whether they were baseball fans, and 36% said they were. Okay. Previously, 37% of a smaller size sample had reported being baseball fans. So when the percents are given, you know that it's a proportion. Okay, the P hat here is 0.36 for I guess 2007, and the number of people sampled is 1,006. And I guess, I mean, I don't know if we need the one for the previous year, but nevertheless, we will not be looking at. So it says in part A to find the margin of error for a confidence level, a C of 0.9. Now, what you have to translate that to, and this is, you know, this is something you probably have seen, is that what they're saying is that 90% of the area is here, and that 5% is there and 5% is there.
Okay.
And you have like tables, but you got to be careful about whether you're given an alpha or an alpha over 2 value, meaning like one-tailed versus two-tailed. And
Okay.
so like, I don't know if that's been covered. Like you have the right Z value, but I wonder if you know where that comes from, or if you know how to calculate the Z value that goes along with the C.
Not really.
Not really. Yeah. Are you using a calculator or a table or both?
A calculator.
Okay, so it's an inverse norm. Okay, and that's going to be under something. Do you have yours out, your calculator out?
Yeah.
Okay, do you remember how to get to inverse norm?
I do not.
All right. Just finding it here because I don't remember either. It's second vars 3. Does that sound right? Second vars gives you the distribution.
Oh, okay, I see it.
Okay, so you wanna choose the inverse norm.
Okay.
Now, what does your screen say for options?
Once you click on inverse norm,
Yes.
it says area and then the mean and standard deviation, tail.
And tail. Okay. So here's how you decide. So the area, we're gonna go with boy, this is maybe unclear. So if you choose the area down here in the lower tail as 0.05, you're gonna get a z value that's negative.
Okay.
Okay. And so if you don't like that, you have to then do 1 minus that. And that will give you a positive. So like the negative one, the negative z is there, the positive z will be there. Or you can get the negative z and then change it to positive. So which makes more sense to you?
The 1 minus 0.5.
Okay. Okay. So that, it'll calculate that. Your mean is 0 and your standard deviation is 1 and your tail is left.
Yes.
Okay, go ahead and calculate that. And tell me what you come up with. Let me know if there's errors or anything also.
I got 0.
Okay. You're using inverse norm.
Yes.
Okay, there's something wrong because that definitely would not work, or it should return 1.65. See, mine's not the same. It doesn't have the same, list here, but let me, can you send me a picture by phone of your screen? The
Yes.
inverse norm screen? Maybe that will help.
Oh, okay. It was my mistake. I put 0.5 instead of 0.05.
Okay. Yes, that will make it 0. Yes.
So I got 1.64 for my
Right. And like a little bit extra. So that's where that
yeah.
1.65 came from. So you
Okay.
always use the C value to turn into one, like you have to get a Z value out of the C value.
Mhm.
Okay, now I got to go back and grab the formula for this. Actually, let me grab it from the other screen. And we'll do this a few times. It's not like, now you know it. I know that wasn't, the computer is, the calculator is not great for doing this, but you have everything you need now. Okay. So you have your p hat. Your p hat is the 0.36. You have your z. That's the 1.65. You have your p hat. Again, 1 minus p hat. You already have that. N is the number of samples. 1006. So you have some options here. Like you can actually enter this in 0.36 plus or minus 1.65 square root 0.36, 1 minus 0.36 over 1006. Now, what's your comfort level trying to calculate this?
It's like just okay. It's not
It's not
super
great.
helpful.
Yeah.
Yeah.
Now your calculator will do, it will do a confidence interval for you. Do you know if your teacher wants you to do it this way or using the calculator feature?
I don't know. I think it's kind of just whatever works.
Okay. I mean, you're going to like the fact that the calculator can do this for you. like,
Uh-huh.
like that's pretty normal. Um, but I worry that that's, what if you don't remember, or, what if it's really hard? Um, I don't know. I don't have a great like feel for what to say. What do you want to do? You want me to show you how to do on the calculator, or talk or work through how to do this on the calculator?
Um, I think like I could do it like solving it on my own. I'd like to see the calculator.
Okay,
Like
you're gonna you're gonna like it here. Okay,
okay.
let me quit out of this. All right, so let me new share that. I've got it up now finally. The calculator thing, and it's, again, mine's an 83, but it's gonna be the same place. You go to stat test, okay, and I'll write this down, but it's not in the same place as what you just did. So there's a lot of things here. There's a z-test, a t-test, and so on. If you go all the way down, you start seeing intervals. See how it says z interval, t interval, 2 samp z
Hmm.
intervals, 2 samp. Well, finally you get to the one you want, which is a 1 proportion z interval.
Hmm.
Let me know when you get there.
Yeah.
Okay, now this one, it has an x and an n. So your n, you got your n down. You're like, oh, my n is 1006. I'm super happy. No big deal there. But your problem did not give you n. Okay, now to calculate n, you take the proportion and you multiply it by n. Now, this is where I can't remember if your calculator will do it. Sometimes it doesn't like when that's a decimal, but that's your x. That's the number of people that in this problem were baseball fans. It's way too high. There's no way there's that many people watch baseball anymore. Now, confidence level, it's a 90%. So you got to take that into 0.9. And then you calculate. So let's give this a try. So see how it has a problem with that?
Hmm.
So you go back to it, and you can get there faster by going up, and it saves it in there. So the issue is that x needs to be a whole number. That's why I said this probably wouldn't work out great. So you can just remove it, and this will now calculate it. It'll be kind of off, but it's going to be close enough probably.
Hmm.
And there it is. It gives you the margin of error. So like if this were a multiple choice test or quiz that you had coming up, if that's what the case, you could then just compare your interval to this one.
Okay.
Any questions on that?
How did you get, let me see. How did you get the 362 for X?
Yes, let's go back to that. Again, I'm going back to test. I'm going up to 1 prop z interval. So initially, like it says in problem 3 that 36% said that they were baseball fans.
Uh-huh.
It's 0.36 times the sample size, 1006.
Okay. Okay.
But then again, yeah, the problem is uh problem is you can't, it has to be a whole number. So you have to know to delete this, because if you run the test with it as is, you would get an error, and then you'd have to know why. And that's not, it's not okay,
Hmm.
Okay, so we can do let's go back Let me actually see, maybe we can just jump to um, another part of this and do another one like this. Okay, so the if we wanted to be 90, if we wanted to do a 99% confident, what would we change in what we just did there? So that's kind of, that's part C.
Mhm.
What would we change?
The confidence level would be 0.99.
Yes. Okay. Now I didn't write the numbers down. So we might have to do this, do this twice, but what you will notice is that it gets wider. So I can calculate this. There it is. Oh, I do think it clears the screen each time. So let me just write these down: 0.335, 0.385. And then if you go back to doing the test again, like you said, and you change it to 0.99, you will see that it gets wider. Okay, so it's
Okay.
0.321 to 0.399. And what you really can't see, and I'll go back to the other screen to show that, is the width. Like on a number line, if you were to just do right minus left on these,
Mhm.
the first one is 0.05 and the second one is 0.078. So that the we talked about that, like from the at the real beginning, is like when you increase the confidence interval or confidence, the C value, when you increase C, it gets wider.
Mhm.
That's kind of a key thing here.
Okay.
All right, so let's look at this number one problem. This is good to look at and see if we can set it up and then use the calculator for it. I hope this is helping. I'm sorry, maybe it seems a little slow, but I hope that we're getting some value out of, getting your value out of this tonight. Because
Yeah.
okay, so there's a lot of information here. The key thing is that when it's a proportion, okay, you have to find your x and your n. So 4781 is your x, and 100,000 is your n. Now, in your previous problem, they gave you p hat. They said p hat is x over n. They gave you that value, but you can calculate it here if you want. All right. The problem is when they don't give it to you. So if they don't give you x, you have to know that x is n times p.
Okay.
All right. So what is the C level in this problem?
The confidence level is 95%.
0.95. Yeah. So you don't have to do anything with your tails or anything like that. You don't have to find your Z's. This one, you just go right to the calculator. So I'd like you to give that a try. See if you can come up with the confidence interval. I will do the same on my calculator, and we'll compare results here in a moment. Let me know if you have any questions or if you got an answer.
Okay.
Do you have an answer for me or question? What?
Um, so for my answer, am I showing like what the two
Ju-
numbers in
That's
parentheses are?
yeah, that's exactly it. That's all they're looking for is the two numbers in parentheses. Yeah.
0.948 to 0.951.
Okay. What value did you put in for X?
For X, I put 95,000.
Okay. So if you're seeing my screen, X is the number of ones that received the donations.
Oh, okay.
So the 95%, you don't multiply that number times anything. You multiply. So I see maybe why you did that because I said it was N times P.
Mhm.
That's if you don't have X.
Oh, okay, okay, that makes more sense.
So give
Okay,
that another
so
try. Yeah, give it another try. It's okay. We just got to get it down. Perfect.
0.046 to 0.049.
Yes, very good. Okay. All right, let me find a couple more proportion confidence interval problems that are maybe are more standard for us here. Proportion confidence interval worksheet. Oh wow, the exact question just showed up in this thing that I was searching for.
Mhm.
Oh boy. Okay. Um, let me see if I can find. You probably did this other one as well. Okay. Let me grab this one, see if this one's any better. Okay. Yeah, let's do this. All right, so here's a new question for you to look at. All right, so I want you to read this over and tell me what either P is or X or N. Tell me what you see after you, or tell me what you see after this.
Um, N is 1505.
Good. I agree.
Um, X is uh X is 1129.
Good. Okay. So now if they wanted P hat, you would take the X and divide it by the N, which is 1129 over 1505. Okay. Now let's say it wanted a 80% confidence interval. Okay, can you calculate that for me with the given information, please?
Mm-hmm. So, Um, so the value of p hat is 0.75.
Okay. But what about the confidence interval? Have you calculated that yet for me? And you can use your
Um,
calculator. No problem
oh,
there.
is the confidence interval 0.73 to 0.76?
Yes. Or 7.4, but yes. Always be careful with what you're rounding to on those.
Okay.
Okay, very good. So let's transition to looking at non-proportions. Okay, so I'm looking at question 1 here, and I think one
Okay.
of the things that happens is like when we do so many problems of the same type, like if you do a proportion and then a proportion, you think that everything is a proportion, but this one is not a proportion. Okay, this one you're looking for, if you go back to the original formulas here, I'm going to go grab a snip of it. Grab the formula here. So you're looking for X bar, S, and N.
Okay.
So go ahead and read this, and this is not right, so don't worry about that. Start fresh. We're practicing for the exam here. Tell me the mean, the standard deviation, and the number of samples here.
Um, the mean is it 343 per gallon?
It is.
Um, and then uh
Standard deviation.
standard deviation is 43 cents or 42.
42.42. Good.
And then n is the sample size, right?
That's right.
Oh, okay, so 10.
You got it. Okay. Now there's a lot of information that's irrelevant in these problems. That's just there to distract you. It's kind of like SAT, ACT stuff.
Mhm.
Now you could use this formula. Okay. Now let's say we're going to do a C equals 95% here. Okay. So we're going to go back to the calculator and we're going to find this test here. So let me go back to the calculator, and it's in the same place as, there it is. It's in the same place as the other ones under tests. This time though, it's a it's a Z interval.
Okay.
Okay. Now this one is different. It's got different things here. This one says input data, which you'll probably do soon if you haven't already. That's if you have a list of data, like if it tells you, all the gas stations, but you don't have that. You have what are the summary stats. So you hit enter on that and notice your list changes. Okay.
Mhm.
Now, I don't know why they want sigma, but sigma in your problem is 2.99. I really don't know why they want that. Anyway, can't do anything about that. X bar is 3.43. Oh, that's why. I'm sorry. I misspoke here. Sigma is the standard deviation.
Oh, okay.
Okay. in your problem, in your exercise, they use S, but you can treat it as sigma here, or S is sigma here. Sorry about that.
Okay.
3.43 is X bar, and then N is 10, and then your C level is 0.95. Okay, so make sure you get caught up there, and whenever you're ready, hit calculate, see what you come up with.
3.16 to 3.69.
Yeah, perfect.
Okay.
Now, what do you think happens if the sample size increases? Like, let's say it goes to 100.
Um,
So it was 3.17 to 3.69. What do you think happens before you do the calculation? Any idea?
would it be like a larger range, like a larger interval?
So this one's not as intuitive. Let's go do the calculation and see. Sorry, I grabbed the wrong one. It's Z interval. And all you're changing is the N value. So let's say, what did I say? 100? 100 sounds
Mhm.
good. So yeah, let's calculate that. So this time it's 3.34 or 35 to 3.551. So if I
Oh,
go
okay.
back, so if I go back to the other screen, okay, you see that, and this is for n equals 10, this is n equals 100. So when you increase sample size, when n increases, the width decreases. And it looks like you get a lot of questions like that on your assignments. If you're ever unsure, you can just go do an interval and then change one thing to the other and see if it's consistent with what you think it should be.
Okay.
All right, so let's try another problem here. If I can't find one, I will look for one. Let me find a new problem here.
Okay.
Okay, so here's one. Let me see if I can. I guess that doesn't matter. They're giving you the answer, but that's not really what I want. I want you to be able to extract the X bar, the sigma, and the N.
Okay.
Oops, that's last two sigmas in a row. And then I guess the C value as well.
X bar is 2.4.
Okay, got it. Yep, great.
Um, sigma is 1.3.
Okay,
N is 20.
all right. And what's the C level?
0.98.
Okay, so go to your calculator, plug these values in, and you should get exactly what's listed here.
My interval is 0.26 to 4.5.
Okay, so got to make sure we get the numbers in the right place. Let me go to my calculator here and share that. Okay, stat test and Z. Okay, we're doing the Z interval 7. Okay. So the sigma is 1.3. Is that what you have?
Yes.
X bar is 2.4.
hmm
And then your sample size is 20. And then your C is 0.98. Does yours match this? If it doesn't,
Yes.
okay. So I'm gonna,
Oh, okay. I know what I did. I put in one of the numbers wrong.
and that will do it. That will, that's enough
Yeah.
here. And so that's the disadvantage or the danger of doing it this way.
Yeah.
All right. So you almost want to double check your calculations or refresh your calculator and do it again, make sure it's the same. There's no partial credit if you're using your calculator because it's, I guess maybe if you have these all listed out, that would be one way.
Yeah.
Okay. Let's look at another one here. This one's got a lot of numbers, a few that you don't need. And again, let's have you kind of do the same thing. I think just pulling out the numbers from the word problem is good. We need the X bar, the sigma, the N, and the C here.
For which problem?
Oh, I'm sorry. I am not sharing the screen again, am I? Darn it. Let me get back to that. Here we go. So yeah, go ahead and look that over. Identify your parameters.
Um, the mean is 11.
Okay, good.
The standard deviation is 1.2.
Okay.
It's a sample of 50 with a confidence interval of 0.9.
All right. Very good. So go ahead and enter that in your calculator and you should get the listed answer here. If you don't, let me know. We can talk about that.
I got 10.117 to 11.883.
Okay. Seems like there must be an error again. Potentially. They could be using something slightly different. So let me go and calculate it as well. There are you're not getting the full information here. There's actually another test you're supposed to be using, but let me just enter it in here and see if I can confirm what you said. 11. N is 50.9. Calculate. All right, so I do get the same one that they have here. Let me go back. Let me share my screen. It's probably just a enter error. Let's go back and look at it again. So, I'm using the stats, 1.2 for the sigma, 11 for the X bar, 50 for the N, and the C level is 0.9. Does yours look different or the same? If it does look different, just modify it.
Yeah, when I type in for N, I typed in 50, but it only, for some reason, it only did 5, and for the last one it did 2 instead of 20.
Okay.
So
Yeah,
I
see,
can
just
do it a second time.
yeah, and like if you're like, okay, 50, hit the down arrow, just make sure it's before you hit calculate, make sure those are the numbers, and then you'll see that, yeah, it does match up there.
Yeah. Okay.
Okay, so let's go back. We're gonna work on, we got one last thing I guess we can look at here. I'm gonna snip in this. So number 6 here. I mean, you're not going to just be calculating confidence intervals. You're gonna get some backwards questions, which are like these, which is, okay, they give you the interval. Okay. They give you the interval. So at one end of the interval is 0.3011. At the other end is 0.4189. Right in the middle is your p hat. So to find the middle number, a couple ways to do it, but it's basically the average. You're just averaging, you're finding the midpoint between these two. Can you calculate that for us, please?
Mm-hmm.
Do you have an answer for me?
0.51.
Okay, did you put parentheses in the numerator? Did you enter
Yes.
this as 0.3011 plus 0.4189, close parentheses, divided by 2? If you try it one more time, just double checking your parentheses.
Okay. Let's see. Is it 0.36?
Yes.
Okay.
Okay, so that's part A. That's the sample proportion. You can think of that as the midpoint.
Okay.
Okay. Now the margin of error, we'll do that in here. It's the distance from the center to the edge point or the other side to the center, either one. And it's probably easier to do it on the left here because it's 0.36 minus 0.3011. My screen just froze up here. Hopefully you saw that. 0.36 minus 0.3011.
Mm-hmm.
Have you had any issues hearing me tonight or any delays on anything?
No, not so far.
Okay. All right, this is still, do you have a number for me on that?
Yes. 0.36. 0.0589.
Good. And then similarly, like if you're like, well, I want to just confirm, if you take 0.4189 and subtract the 0.36, that will give you, should give you the same result. That is also the margin of error.
Okay.
All right, we're going to stop right here.